Hey, so we're going to do denormalized floating point calculations for IEEE 754. And if you haven't watched the normalized video, I just want to warn you, I am a student. So like you, maybe some of you, I have struggled with this concept and I'm solidifying it in a video. And if you don't know already, I threw together a PDF that I hope clarifies this a little better as well. So, defining what each one of these variables mean, what they represent anyway, as well as the normal and denormalized formulas. So, these are correct. Spelling may not be, but the steps to get to the solution are. Each one of these cameras represent a link. They'll take you to a YouTube video. There's normalized, denormalized, and I do not think I'm going to do a video on the special cases because they're really straightforward. If the exponent field's all ones, hey, it's going to be one of these three cases. And then you just need to look at and pad the higher order bits correctly, partition them correctly, and you'll figure out if it is positive or negative infinity or not a number. Anyway, that said, I did put this together in white, gray, and blue for your viewing pleasure. All right, let's do this. So, denormalized float. The calculation for that is going to be V of denormalized, -1 raised to the sign bit multiplied by, and in this case, it's just going to be the fraction value. There is no floating one in this case, so fraction multiplied by 2 raised to, and in this case, it's going to be just a constant one less the bias. So a couple of differences. All right, let's start out with a input for our program. So let's say that we're given 3, 4, and a hex of 7. And it's not going to come in this way with 0x, but just to clarify what that is. So we have our fraction field, we have exponent, and we have hex. So the first thing I'm going to do is I'm going to convert my hex value into a binary. So my first step, so step 1 is going to be convert hex to bin. All right, so 0x7, well, that's just going to give us 4 bits. And if you're on a Windows, you can pull up the calculator, go down to programmer, click on hex, enter 7. That'll give you the binary 111. All right, so we're going to have a binary of 111. Well, there's a problem. We have 3 components in the fraction field that we can partition, but we need 4 in the exponent field. Well, in this case, we are told that we do always 0 pad the higher order bits. So let's do that. So we have 3, we need 4 for the exponent field. And then we're going to need 1 more for the sign bit. All right, now let's just make this a little cleaner. So in step 2, what I'm going to do is just lay out each one of these individually. So we're going to have our fraction. And we're just going to bring down what we have for the binary representation of the value. That we know is equal to 7 in decimal as well as hex. Now, exponent, we're not using its decimal value. We're going to use the number of bits in our calculation. So let's just jump and throw our sign bit in here. So the sign bit is 0. Of course, that's going to be -1 to the 0 is just going to be 1. Okay, so for the third step, I like to find the bias before I do the fraction. So let's do bias. And the bias is the same calculation for normal and denormalized. That's going to be 2 raised to the k less 1. All of that less 1. And k is going to represent the number of exponent bits. And we were given that the exponent bits are 4. Even though they're all 0, we do use the exponent bit value there. So we're going to say 2 raised to the 4 less 1, all of that less 1, and that gives us 7. And no, it won't always be 7. That's what you were thinking. So now we're on to number 4. Now we're going to do the fraction value. And fraction is different. So for denormal, again, we don't have that floating point, or floating point. We don't have that floating 1. So it would essentially be 0 plus. And what we're going to do is take that bit representation. So we have 3 bits that were given. We know that that is a value of 7 in base 10 or decimal. And I'm going to take my actual value in decimal, place that in the numerator, and I'm going to divide by my base 2 binary, raised to the total number of bits, which is 3. And that's going to give us 7/8, which is 0.875. All right. So now we have everything we need to put this together. So let's go ahead and solve this down for the floating point. And what I'm going to do is I'm just going to list out in step 5 everything we found, everything we've been given. So we have a sign bit. It's going to be a multiplier of 1. We have our fraction. And that is 0.875. Our exponent is just all zeros. We're not going to include that, but we do have the bias. And our bias, we said, was 7. So our denormalized value is going to be positive 1 multiplied by our fraction value, 0.875. That's going to be multiplied by 2 raised to the constant 1 less the bias. Now, in this case, you can see that we're going to end up with a negative exponent. So a negative exponent is just simply the same as saying divide by 2 raised to, and if we took the bias less 1, we'd have 2 to the 6. So that's the way I would calculate it. And if we do it that way, let's take a look here. We're going to end up with, well, that didn't help. Scientific, and we're going to take 0.875 divided by 2. Oops, because I haven't used this in a while. I need my TI-89. I'm going to pause this real quick, break out my TI-89, and I will be right back. All right, so that came out to a fraction of 7 over 512. And that's going to give us approximately, and I say approximately because in our program we're going to have 6 places of precision after the decimal place. So we're going to have 0.01367, and then we'll round this to 2. All right, so that is what we're going to get for a value there. I did want to share. Let me see here. I'm pretty sure I already did this. It's really late and I am super tired. But anyway, yeah, here's the PDF. All of this is going to be on there. Okay, I hope this helps. This has been rough. But anyway, uh, these are the steps I took to build my program. It does work. I have verified this with Ted, and hopefully this helps you guys out. So thanks for watching. Good luck.